In this tutorial, we're going to be looking at work and energy problem set B, and it's going to be kinetic energy. So recall that kinetic energy is 1/2 mv squared, as it shows here. So the one that we're going to look at for today is problem number 7. So let me slide this over here so we can look at the problem. It says the brightest and hottest, most massive stars are the brilliant blue stars designated as spectral class O. If a class O star with a mass of 3.38 times 10 to the 31 kilograms has the kinetic energy of 1.10 times 10 to the 42 joules, what is the speed? Express your answer in kilometers per second, the typical unit to describing the speed of stars. All right. A couple reasons why I picked this one, and in particular, is that the numbers are so large, and a lot of you have phobias of large numbers, so and how to deal with them. So let's take a look at this. And as usual, what we should start off with is talking about the givens. So this is problem set B and problem number 7. So the givens in problem 7, we got mass, and the mass is 3.38 times 10 to the 31 kilograms. And then we have the kinetic energy. So kinetic energy equals 1.10 times 10 to the 42 joules. Now it's not as easy just to, we just don't divide the two because that's not what this is about. Okay, what we're looking at is the fact that we have kinetic energy equals 1/2 mv squared. We're looking for V. We're looking for that one right there. So we have to do simple algebra to get it to V. So we need to isolate V, get it by itself. So here we're dividing by 2, so we're going to multiply by 2. Here we're multiplying by m, so we're going to divide by m. And then we're squaring V, so we're going to take the square root of it. So what it's going to look like is this. V is equal to 2 kinetic energies divided by the mass, and then we're going to take the square root of this whole thing. Right? So that's the formula we're going to use for this particular one. Now, over here is where I'll do all of the math for it. So V equals, and then we're going to start off with 2, and I'm going to do this in dimensional analysis form, like this. Okay, kinetic energy is 1.10 times 10 to 42 joules. And then we've got mass in the bottom, which is 3.38 times 10 to the 31 kilograms. And all of this is going to be square rooted. Okay. All right. So once again, let's take care of the powers of 10. Okay, I've got 10 to the 42 divided by 10 to the 31, so I subtract my powers of 10. So 42 minus 31, that leaves us with 10 to the 11. And this is going to be meters squared per second squared. Okay, so now I've got rid of the powers of 10. I don't have to deal with those, so I just deal with these guys right here. So I bring over my handy dandy calculator, and all I do is I go 2 times 1.1, which we could have done that in our head, 2.2, divided by 3.38 equals, and we get 0.651. Okay? And this is also going to be square rooted. Okay, B equals. Now I've got to put this into standard form. Okay, so I'm going to multiply this by 10, which takes this down to 10. Okay, 11 turns to 10. So my velocity equals 6.51 times 10 to the 10. Once again, meters squared per second squared. I have not done my square root yet. Many of you forget to do the square root. You just drop it off for some reason and leave it alone. I've got two numbers here. Okay. A square root for powers of 10 are like a power of 1/2. Okay. So basically what we're looking at here is, and don't write this down, but basically it's 10 to the 10 to the 1/2 power. Okay. So what I'm going to do here is I'm going to multiply these, but what's half of 10? So that is, I don't want you to write that down. I'm just telling you that's the way you can do it in your head. Okay. But we can always do it with the calculator here. Okay. So I'm going to clear this one here, and I'm going to say square root. And I'm going to start off with 6.51. And then this key right here that says x to the y, that's the one that I'm going to use. Okay, so I'm going to say times x to the y. Oh, I've got to do a 10 first, sorry. 10 x to the y. And now I can put in 10. And then match up the parentheses. I have parentheses for these two here. I need parentheses for this one also. Okay, and then that'll do the whole thing. So when I hit equals, I end up with 255,147. Well, I don't need all those numbers, so all I'm going to use is velocity equals, and this is going to be 255, and I'm just going to put zeros at the end of that, 0, 0, 0. And this will be meters per second. Now I'm going to put it into scientific notation. 2.55 times 10 to the 1, 2, 3, 4, 5 meters per second. Okay. Now, the question did ask us to put it into kilometers per second. Okay, so how many meters in a kilometer? It's 10 to the 3 meters per kilometer. Cancel the meters, I get kilometers per second. This is how dimensional analysis works. Make sure that you're in the right units. Okay, I've got 10 to the 5 divided by 10 to the 3, subtract. Then I subtract the exponents, and so I get 10 to the 2. So this is 2.55 times 10 to the 2 kilometers per second, or I can write down 255 kilometers per second. And there is my answer. Okay. All right. So in this particular problem set, we have 9 problems. So I want you to do 6 out of 9. Once again, this one doesn't count, so it's really 6 out of 8. Okay. All right. Thank you, and good luck.